Hey everybody, and welcome to a video on Jeffrey Conditionalization. Recall that in the last video we talked about the principle of conditionalization. And let's remember what that was. Conditionalization. Right? This told us how to update or change our probabilities when we receive new information that comes in propositional form. Right? So if I have some initial probability judgments, and then I learn some new proposition E, then my new degrees of belief, my probability new, should be equal to the old probabilities conditional on that proposition that I learned. Right? This is the principle of conditionalization. Now, what if our learning experience doesn't come nicely packaged as a proposition? Right? What if we have a more general sort of learning experience? That's what Jeffrey conditionalization is supposed to account for. This was a method proposed by the philosopher Richard Jeffrey for how to update our probabilities when we have a learning experience that's not exhausted by learning a particular proposition. So what's the idea here? Well, it may be best to introduce this by considering an example. So in the last video we used a coin example. Let's use a card example here. Let's suppose that we're going to draw a card from a standard 52 card deck. Now, let's suppose that I'm interested in the probability of getting a heart. Right? A heart card. Well, we know that antecedently, right, before I draw anything or learn anything, that's a 1/4 probability, because 1/4 of the cards in the deck are hearts. Now, let's suppose that someone draws the first card from the deck, but I don't see it entirely well. Right? I just catch a sort of partial glimpse of the card. And it appears to me, from the experience that I have, that the card is likely red, but I don't get a good enough direct visual experience of the card to say that for sure. It just seems more likely to me that it's red, right? So what we might have then is a case where my initial probability for the card being red is 1/2, right? Because half the cards are either hearts or diamonds, and so red. And that transitions to a new probability where for being red that is not quite 1, but also greater than 1/2. Maybe it's now 3/4. Maybe I'm 75% confident that the card is red after I have this visual experience. So this is a case where I haven't learned a proposition for sure. I haven't learned for sure that the card is red, or that the card is black, or the card is a heart, or the card is a diamond, or an ace, or a king, or any sort of definite fact about the card. All I've had is this experience that has changed me, that's caused me to adjust how confident I am of the card having certain properties. In this case, of the card being red, right? Now, what's happened then is that we have a learning experience that's not captured by a particular proposition. Rather, the learning experience is captured by revised probabilities over a particular partition here. Revised probabilities over a partition, right? This is a logical partition of propositions. What's happened in this case is I've gone from saying the probability of red equals 1/2 and probability of black equals 1/2 to saying now that the probability of red is 3/4 and therefore the probability of black is 1/4. Probability nu of black equals 1/4. All right, so this is a different way of viewing a learning experience now. Instead of learning a particular proposition for sure, I'm shifting my probabilities over some partition of propositions. Now we can ask, how should the rest of my probabilities be revised in light of this, right? And this is where Jeffrey conditionalization comes into play. So Jeffrey conditionalization. According to Jeffrey conditionalization, if my learning experience is captured by a shift in probabilities spread over a given partition, maybe E1 through En, then Jeffrey conditionalization says that my new probability in an arbitrary proposition X should be equal to my old probability in X conditional on the first cell of the partition, E1, weighted by the new probability of that cell, plus my old probability in X conditional on the second cell, weighted by the new probability of that second cell, and so on, all the way till the final cell of the partition. Right? Probability of X given En times the new probability of En. All right, so this gives us a way to update our probabilities when our learning experience consists in shifting our probabilities over a particular partition of propositions. So in this example, what we're doing, we had the probability of red starting out as 1/2, and similarly probability of black starting as 1/2, and then I have a visual experience that causes me to shift those probabilities to now being 3/4 on red and 1/4 on black. Now I can ask, right, question, what is the probability, my new probability, of, say, a heart, right, in light of this learning experience? Well, let's use Jeffrey conditionalization, right? It would be the probability, my old probability, that I would get a heart, right? Given, right, here the partition is red versus black. So it would be that I'd get a heart given that it's red, times my new probability for it being red, plus my old conditional probability for getting a heart, given that it's black, times the new probability that it's black. Okay? Now let's see if we can solve this. So we know that my old probability that was heart, given that it's red, is 1/2, because half of the red cards are hearts, right? And the other half are diamonds. My new probability that it's red is 3/4, right? 3/4. Now, my old probability that it's a heart given that's black is 0, because it couldn't be a heart if it's black, and your probability of black is 1/4. So this whole thing ends up being 3/8. Right? So my probability went up that it's a heart. Initially I started out, it's only probably 1/4 or 2/8 that it's a heart, and I went up to probably 3/8 that's a heart. Once I have this experience, it makes me think it's more likely that the card is red rather than black. Though note that it doesn't go up as much as it would if I learned with certainty that the card was red, right? If I learned with certainty that the card was red, then we'd be in a case where standard conditionalization could apply, right? I learned the red proposition, right? So in that case, right, the probability would have increased all the way to 1/2, because it would have just been equal to the old probability of getting a heart given red, which is 1/2, right? Now note, right, that Jeffrey conditionalization is a generalization of conditionalization, right? Or we could say conditionalization is a special case of Jeffrey conditionalization, right? It's the case where you learn a particular cell of a partition with probability 1, right? So if I shift, right, we can see this, right? Looking up here at the formula for Jeffrey conditionalization, right? If I were to learn a particular proposition, say E2, right, with certainty, I knew that was true, then, right, the new probability V2 would become 1, right, here, and the probabilities of all the other cells of the partition would be 0. So all those other terms would fall away, and I would just have that the new probability of X is equal to the old probability of X conditional on the proposition I just learned. Oh, but that's just conditionalization, right? So Jeffrey conditionalization is a generalization of conditionalization, right? We can update by Jeffrey conditionalization in all the cases we could by update by conditionalization, and we'll get the same answer, but we can also update in a broader range of cases using Jeffrey conditionalization. Okay, we'll get some more practice with this going forward in homeworks and exams. If you have any questions about it, please reach out to me or reach out to the TAs. Please remember to complete the participation poll for this video, and I'll see you guys next time. Thanks, guys.